Dear students, welcome to my fourth class on Module 2, Conformal Transformation and Complex Integration. In this lecture video, we're gonna see about Cauchys integral formula and general form of Cauchys integral formula. Cauchys integral formula statement: if f of z is analytic inside and on a simple closed curve C, and A is any point within C, then f of A is equal to 1 by 2 pi I integral over the region C f of z by z minus A into dz. So here I am taking z minus A as a circle with center at A, and we shall enclose this circle C1 with another circle called C of radius r. So hence I am going to assume that this curve C1 lies entirely within C1. So from the graph we can see that in the XOY plane I took two curves. One curve is C and one more curve is C1. This curve C1 is contained in the curve C of radius A and center at the point A. So now we can tell that the function f of z I z minus A is analytic inside and on the boundary of the annular region between C and C1. Now from the consequences of Cauchy's theorem, we have the formula like the integral over the region C f of z by z minus A dz will be equal to the integral over the region C1 f of z by z minus A into dz. So here I am using the consequence number 2. So since here the C1 is a circle with center at A and radius r, so we have the equation for circle in the form of z minus A is equal to r into e power I theta. So I'll be getting z is equal to a plus r into e power I theta. So now we have to find the value of dz and we have to find the limit for theta also. Now by differentiating this equation, I'll be getting the equation for dz. So dz is given by r into I into e power I theta into d theta, and here the angle theta varies from 0 to 2 pi. Now I'll be replacing all this data in the previous equation. So I'll be getting the integral over the region C f of z by z minus A into dz will be equal to integral between 0 to 2 pi f of A plus r into e power I theta by r into e power I theta into r into I e power I theta d theta. So I'll be cancelling r into e power I theta and r into e power I theta, and this constant I am taking outside. I got the equation like this. The integral over the region C f of z by z minus A into dz will be equal to I into integral between the limit 0 to 2 pi f of A into r into e power I theta d theta. So since in the circle C1 I am going to assume that the radius is too small. That is, if r tends to 0 in the previous equation, the equation will become like this. Integral over the region C f of z by z minus A into dz is equal to I into integral between the limit 0 to 2 pi f of A d theta. Now since here this f of A is a constant, I am taking outside. After integrating the constant, I'll be getting theta here between the limit 0 to 2 pi. So I got the equation I into f of A theta between the limit 0 to 2 pi. Applying upper limit, I'll be getting 2 pi I, and for lower limit it will become 0. So I got the equation. The integral over the region C f of z by z minus A into dz is equal to 2 pi I into f of A. Since here I need to find the value of f of A, I am shifting this 2 pi I to LHS. So I got the equation f of A is equal to 1 by 2 pi I integral over the region C f of z by z minus A into dz. So this formula is called the Cauchy's integral formula. So now I'll be deriving the Cauchy's integral formula in the general form. The statement is if f of z is analytic inside and on a simple closed curve C, and if A is a point within C, then the formula is given by f power n of A is equal to n factorial by 2 pi I integral over the region C f of z by z minus A whole power n plus 1 into dz. Here he has to come here So now to prove this one, I am going to make use of the Cauchy's integral formula. It is given by f of a is equal to 1 by 2 pi I integral over the region C f of z by z minus a into dz. So now I am going to differentiate this equation partially with respect to a. So it will become f dash of a. So by d by d a of f of a will become f dash of a. I am taking the constant 1 by 2 pi a as a outside, and here integral f of z into dou by dou a of 1 by z minus a into dz. So now differentiating 1 by z minus a with respect to a partially, we'll be getting minus 1 by z minus a whole square, and solving this minus a will be getting minus 1 again. So I got the equation like 1 by 2 pi I integral over the region C f of z into minus 1 by z minus a whole square into minus 1 into dz. So hence it will become 1 by 2 pi I integral over the region C f of z by z minus a whole square dz will be getting. So I got this equation. Now again differentiating this equation partially with respect to a. So it will become what? This f dash of a will become dou by dou a of f dash of a. It will become f double dash of a. The constant I am taking outside 1 by 2 pi I. So the integral over the region C f of z I am keeping as it is. Differentiating 1 by z minus a whole square, I will be getting minus 2 by z minus a whole cube, and solving this minus a will be getting minus 1. So I got the equation f double dash of a is equal to 1 by 2 pi I integral over the region C f of z into minus 2 by z minus a whole cube minus 1 into dz. So it will become 2 by 2 pi I integral over the region C f of z by z minus a whole cube into dz, or we can rewrite this equation as f double dash of a is equal to 2 factorial 2 pi I integral over the region C f of z by z minus a whole power 2 plus 1 into dz. I'm just converting the entire equation in terms of two terms. So now in the same way, like after differentiating for n times, the previous equation will become f power n of a is equal to n factorial by 2 pi I integral over the region C f of z by z minus a whole power n plus 1 into dz. So this equation we can obtain by using the previous one only. By replacing n is equal to 2, we can able to get this equation directly. So this formula is called the general form of the Cauchy's integral formula. Now problems on Cauchy's integral formula. So now in this video I'll be discussing how to solve the problems only. The working rule. The first thing is, if the given integral of the form, the integral over the region C f of z by z minus a into dz, or the integral over the region C f of z by z minus a whole power n plus 1 dz over a simple closed curve C. So for these kind of problems we have to use only the Cauchy's integral formula, and for this kind of problems we have to use the general form of the Cauchy's integral formula. The step 1 is we have to find out the point z is equal to a lies inside or outside the given curve C. In the first step, always we have to find out that the point z is equal to a lies inside or outside the given curve C. This is the first step. Step 2. In the step 2 we have two cases. In the case 1, if z is equal to a point lies outside the given curve C, then the formula will become 0. That is, the integral over the region C f of z by z minus a into dz will become 0, and the integral over the region C f of z by z minus a whole power n plus 1 into dz will become 0. This is when means the point z is equal to a lies outside the given curve C. Case 2. Suppose the point z is equal to a lies inside the given curve C. Then the formula we have to use is the integral over the region C f of z by z minus a into dz is equal to 2 pi I into f of a, and we have to find the value of f of a also to replace here. Similarly, the integral over the region C f of z by z minus a whole power n plus 1 dz can be taken as 2 pi I by n factorial into f power n of a. So here we have to find this, the value of f power n of a. So to find these two values, I am going to make use of the function f of z from the given problem. Okay, in the next lecture video, we'll be discussing the problems on Cauchys integral formula and the problems on the general form of Cauchys integral formula. Thank you.